helium, neon, argon, krypton, xenon, and radon are collectively called these 18th group elements. These 18th group elements like helium in Greek language, helios, nothing but the sun. This is helios. All the Greek words are the neon. This is neon indicates neo, indicates this is a new element. Argon. Argon is nothing but argos, nothing but lazy. Do not react easily. Lazy element. Krypton. This krypton, kryptos is nothing but stranger. Stranger, this is. Like xenon, that is xenon is nothing but hidden like. The radon is a radioactive element. It is a radioactive element. So based on their nature, based on their discovery, based on their concept in Greek language introduced all these names: helium, neon, argon, krypton, xenon, and radon. Okay. Now here these helium, neon, argon, krypton, xenon are generally called noble gases. Why these are called noble gases? So why these are called noble gases means these compounds are rarely available. These compounds are rare. Compounds are rare, that's why they are noble, peculiar, noble compounds, noble gases. These are called zero group elements. Why these are called zero group elements? Here these zero group elements means here valency, combining capacity. Valency is equals to 0. Zero valency. That's why here zero group elements, because NS2 NP6 is the general electronic configuration. It's in its outermost orbit. NS2 and NP6 completely filled electronic configuration is there. Completely filled electronic configuration EC, except helium. Now here the helium has a duplet electronic configuration. Duplet EC this is. Duplet means helium has like NS2 only, that is 1s2 electronic configuration. That's why these are called zero group elements. Now these are also called a rare gases. Why these are called rare gases means the availability of these gases except radon is very less. So the very less quantity available, quantity that is quantity available in atmospheric air. In atmospheric air, that is by its volume nearly 1% by its volume available. Rare gases, rarely available, less quantity. That's why they are called rare gases. These are also called a inert gases. Why these are called inert gases? So they are chemically chemically inactive gases. Inactive they are. Inactive, that is due to octet electronic configuration or a completely filled electronic configuration. That's why they are called inert. Do not lose, do not gain electrons. So under normal condition, initially these elements do not gain or do not lose electron. That's why they are chemically inactive. That's why they are called inert gases. These are also called aerosens. Aerosens mean they are available except Rn, they are available in atmospheric air. They are available in atmospheric air. That's why atmospheric air. That's why they are called aerosens. So here these are generally called noble gases, zero group, rare gases, inert gases, aerosens. All these are arranged under 18th group in the long form of the periodic table. That is P block elements. P block elements means except helium. Helium electronic configuration is 1s2. The last entered electron enters into a S subshell. Originally, this helium is inserted in S block, but even though the last entered electron enters into a S subshell, even though it is arranged in a P block, because this helium has a duplet electronic configuration, stable electronic configuration, and it shows the properties of neon, argon, krypton, and xenon. Shows like a similar properties. That's why even though it has S electronic configuration, like S block element that is arranged in a P block that is under 18th group elements. Okay. So why these are called noble gases, zero group, rare gases, inert gases, and aerosens concept this is. So elements names like helium, neon, argon, krypton, xenon, and radon like meaning. So by using this, by using all important points in atmospheric air, among all these, our main atmospheric air contain atmospheric air contain 1% by its volume. So in this 1% by its volume, your argon availability is more than compared to the neon, than compared to the helium, than krypton, and it is xenon. This is by its volume. By its volume order it is. By its mass order availability order occurrence is argon, that is neon, krypton, xenon, and helium. These two are very, very important. So by using these either by volume or mass, whatever it in atmospheric air, the main constituent element present in atmospheric air is argon. So by using this, the main source for argon is air is atmospheric air. Atmospheric air is the main important source of argon. Then natural, here the main source for helium, that is helium is natural gas. So the natural gas mainly contain like helium. Already given in 2 to 3 times in examination, the main source for argon is atmospheric air. The main source for helium is natural gas. Now here the krypton, xenon and radon rarely available in atmospheric air, less minute quantity. By the radioactive disintegration of radium, like radium 88 to 236, 226, on disintegration it gives corresponding radon 86 222 plus helium 224 is formed. Means helium also obtained by the disintegration of radioactive elements like radium to radon and helium gas like alpha particle like. So for this helium and neon, these radioactive elements like pitch blende, monoxides, are the clevite are the some important sources to get helium and neon gases. These are the some important points about sources of some noble gases. So very, very important concept already given in PU examination in subjective concept. Yeah, the main sources of argon and helium are the main important points. So after this, electronic configurations of noble gases, 18th group elements. Electronic configurations of 18th group elements are the general electronic configuration of 18th group elements is NS2 NP6 is the general electronic configuration of 18th group elements. Your N stands for energy level, that is 2, 3, 4, 5, 6 and so on. So by writing electronic configuration, NS2 and NP6 are the S subshell contain 2 electrons that are completely paired, and P subshell contain 3 degenerated orbital. Each degenerated orbital contain 2 electrons, means it is completely filled, and P also completely filled. That's why it is completely filled electronic configuration. Now completely filled means S2 electrons and P subshell contain 8 electrons. That's why it is called a octet electronic configuration, that is except helium, remaining all elements having octet electronic configuration, that is NS2 NP6 electronic configuration. So by using this, here element is first element is helium, and symbol and atomic number is helium like 2, and its electronic configuration is AC is 1s2. This is 1s2. Here 2s 2p, there is no 2d orbital. Now it is general electronic configuration of 18th group elements. For that helium is like a symbol and electronic configuration is 1s2, 2s2, 2p. Sorry, 1s2, 2s0, 2p0. There is no 2d orbital. In its outermost orbit, it contains only 2 electrons. That's why this is called a duplet electronic configuration. The last entered electron enters into the S subshell, even though it is arranged in a p block, because this element and the remaining elements are these group elements shows almost all same properties. That's why this is arranged under 18th group elements. That is the first member of 18th group element. The next one is neon. Your symbol is Ne. To this add 8, that's 10. For that 1s2, 2s2, 2p6 and 3s, 3p. Like there is no 2d orbital here. Here also there is no 2d orbital. Next one is argon. For this argon 18 atomic number, its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 3d is there. For this we can write 18 for next element. Krypton. For that krypton now, to this 18 add again 18, 36. For this we can write argon 18, 3d 10, 4s2 and 4p6 is the electronic configuration. 18 plus 18, 36 balanced. Xenon. To this xenon 54 add 18 will get 54. To this we can write here krypton 36. The 4d 10, 5s2 and 5p6 is the electronic configuration. Then here radon, symbol is Rn, add 32 will get 86. That is xenon 54, 4f14, 5d10, 6s2 and 6p6 is the electronic configuration of radon. So this is the complete electronic configuration of these 18th group elements, except this helium in its outermost orbit, like 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 5s2, 5p6, 6s2, 6p6, all are having octet electronic configuration. This is ns2, np6, that is the stable electronic configuration, EC. So in the long form of the periodic table, each and every one element try to get this electronic configuration either by losing or gaining or sharing of electrons from its outermost orbit. For example, the sodium is there, first group element. Its electronic configuration is, its atomic number is 11. Electronic configuration is 1s2, 2s2, 2p6, 3s1 this is. In the long form of the periodic table, this is the first group alkyl element, that is sodium. In its outermost orbit contain only one electron. That's why sodium is ready to lose to get this electronic configuration. This is the neon electronic configuration. Neon is the stable octet electronic configuration, 2s2, 2p6. So here the each and every one element in the periodic table, not only this sodium, any element in the any periodic table based on their number of valence electrons, based on their capacity, combining capacity, some are ready to lose, some are ready to gain. Now the sodium is ready to lose one electron. Sodium Na in gaseous state loses one electron, it gives Na plus. Now this is the neon electronic configuration, like 1s2, 2s2, 2p6, ready to lose. Chlorine is there, 17 atomic number. To get the stable octet electronic configuration, chlorine atom ready to accept one electron. After accepting one electron, it becomes Cl minus. That is chlorine we know 1s2, 2s2, 2p6, 3s2, 3p5 is the chlorine atom. After accepting one electron, it becomes argon electronic configuration, that is neon 10, 3s2 and 3p6 electronic configuration. That's why in the long form of the periodic table, each and every one element try to get this electronic configuration either by losing or gaining or sharing. For what purpose? To get the stable nature of that particular element. So the sodium, after losing one electron, it becomes stable in Na plus ion, neon electronic configuration. Chlorine, after gaining one electron, it becomes argon electronic configuration, that chloride ion becomes stable because it attains a stable octet electronic configuration. That's why here these 18th group elements electronic configuration or the stable electronic configuration in the periodic table, each and every one element try to get this electronic configuration. That's why these are arranged extremely right hand side of the periodic table. In the long form of the periodic table, these elements are arranged extremely right hand side because try to get this electronic configuration either by losing or gaining electrons. So originally, its position is in between the S block and the P block elements. So original position. This is the long form of the periodic table. In this long form of the periodic table here. Now, bottom of the periodic table, one separate block is there, that is F block. Now, this is the S block, this is the P block, this is the D block, this is the F block, this is. Now, for this oxidation state, positive values are there, +1 and +2. Here also, positive values are there, D block elements. Now, here, positive slowly values are negative values increase. Last 17th group elements like fluorine shows -1 oxidation state, whereas these 0 group elements, its valency is 0, oxidation state is 0, combining capacity is 0. They do not exhibit any oxidation state under normal conditions. That's why helium, neon, argon, krypton, xenon and radon are in this 18th group, 0 group. Originally, these are arranged between positive and negative values. That's why its position is intermediate between S block and P block. But not like its position is arranged extremely right hand side because either S block or D block or P block try to get this electronic configuration either by losing or gaining of sharing of electrons. That's why its position is in the long form of the periodic table extremely right hand side of the periodic table. That is the position in this all these elements having a stable octet electronic configuration. Valence is 0, combining capacity is 0 under normal conditions. Clear? On the basis of electronic configuration, first one is atomic radius, some physical properties. Atomic radii. What happens? Atomic radii. Now here the atomic radii, then here density of this. Now here solubility of this. Then here polarizability of these elements. Now here diffusion, here ionization energy, thermal conductivity. These are some important properties. So ionization energy, thermal conductivity and diffusion, and these are some important points. Atomic radii, density, solubility, polarizability, like. So once we can observe for all these, maybe 1 mark they'll ask, like So the atomic radii means based on their electronic configuration ns2 and np6. Your n value is 2, 3, 4, 5 and so on. Top to bottom atomic number increase, a newly added electron enters into a new main energy level. That's why size what happens increases. That is generally your helium to the xenon. Radon is a radioactive element. Atomic size what happens increases. The symbol indicates increases. Atomic size increases. Whenever atomic size increases, density is equals to mass by volume. Mass by volume. Whenever atomic size increases, simultaneously volume increases, proportionately mass also increases. That's why your helium to the xenon, its density increases because atomic radii increases. Now here the whenever atomic mass increase, van der Waals forces here generally between all the elements are monoatomic gases, weak van der Waals forces are there. Solubility increase from helium to the xenon like. Then here polarizability in chemical bonding explained polarizability, polarizing ability also here increase xenon to the helium to the xenon increases its polarizability. Also here melting and boiling points also here increases. Melting and boiling points increases. These are some important points regularly rises with increasing atomic number. Now this is diffusion, ionization energy and thermal conductivities decreases from helium to the xenon value decreases. Now here also ionization energy also here to here decreases and thermal conductivity helium to the xenon values decrease. Symbol downward indicates it is decreases. Now here the ionization energy and diffusion thermal conductivity is decrease. Here we know ionization energy top to bottom size atomic size increases. Between nucleus and outermost electrons are loosely bonded. Now top to bottom size increases, ionization energy decreases. Among all known elements, helium has highest ionization energy, IE or ionization potential because of its small size and duplicate electronic configuration. So due to the small size and duplicate electronic configuration, helium has the smallest, means the smallest size and has the highest ionization energy among all known elements. So the top to bottom size increase, ionization energy decreases. And here the diffusion also, these gases are diffused through plastic or any polymers, polythene materials. Whenever atomic mass increase, diffusion power decreases. In first PUC gaseous state explained to you, a fusion and a diffusion, escape of the gaseous molecule from high pressure region to a low pressure region, diffusion this is. This diffusion whenever molecular mass increase, diffusion capacity decrease, cannot escape easily. That's why the helium atomic mass is less, they are easily diffuses through a material, plastic or the polymer materials. That's why diffusion capacity decrease from helium to the xenon. These are some important points about 18th group elements like helium, neon, argon, krypton, xenon and radon. These properties are very, very important properties. In examination, they'll ask increasing or decreasing order like atomic radii, like helium is less than, neon is less than, or argon is less than, or krypton, xenon, radon is a radioactive element decrease. Like they'll give some important examples. So instead of like, remember like this also, order, increasing or decreasing order. Yeah, the helium to xenon, this atomic radii increases, like increasing order. So for all these, make a one flow chart and prepare it increasing and decreasing order of all these. Okay. Next, some important, another important points about 18th group elements. Your electron affinity or electron gain in enthalpy, this is. So generally, electron affinity means minimum amount of energy is released. Minimum amount of energy is released when one electron is added to the isolated neutral gaseous atom. So to the X element, isolated neutral gaseous atom, one electron is added, it becomes X minus in a gaseous state. Now that electron affinity value, that is delta H electron affinity value is negative, because after adding one or more electrons, some amount of energy is released. It is an exothermic process. After adding one electron to this uni-negative, one more electron is added, it becomes bi-negative, that is EA1. This is EA1, this is the EA2. Now this value slowly, negative value decreases, positive value increases. Positive value increases. So to overcome this, already in a uni-negative ion, already a negative charge is there, electron charge also negative. To overcome this negative and negative inter-electronic repulsive forces, the released amount of energy is utilized by this electron to add into this uni-negative ion. This is a uni-negative ion. To get the bi-negative ion, here this value, EA2 value is slowly, negative value decreases, positive value increases. But here noble gases like helium, neon, argon, krypton, xenon, like these elements shows here positive electron affinity values. There is no negative values. So there are positive values changes. So depending upon the element, here positive values changes. All are having do not having same positive values. So do not show any negative values. Shows here positive values. So positive values increase or the decrease based on their size and attractive forces. So on the basis of all these physical points, these noble gases are colorless, are the tasteless monoatomic gases. Monoatomic gases these are. In physics already explained, and in chemistry also, in thermodynamics explained, Cp by Cv is equals to gamma. Its value for monoatomic gases is 1.66. So here on the basis of thermodynamic properties, monoatomic gases like Cp by Cv value, that is gamma, that is equals to 1.66. Those who are having this 1.66 value, gamma value, Cp by Cv, heat capacity at constant pressure, heat capacity at constant volume ratio must be equal to this value equal to 1.66. They are considered as monoatomic gases. So why these are monoatomic gases? On the basis of this thermodynamic as well as based on MOT, molecular orbital theory, explained to you in first year in chemical bonding. On the basis of molecular orbital theory, for all these noble gases, it's a bond order BOIC equals to 1 by 2 into NB minus NA value. This is, that is 1 by 2 into NB value and NA value. Equal number of atoms are present, electrons are present. That's why this value is equals to 0. For noble gases, bond order 0 means there is no bond between helium or any noble gases. That's why they are monoatomic gases. Due to this, between helium and helium or noble gases and noble gases, only there exists a weak van der Waals forces. Weak attractive forces exist. There are weak van der Waals forces. Van der Waals forces exist between helium or neon. There is no accurate bonds like covalent bonds. Bond order value is equals to 0 and Cp by Cv value is equals to that. That's why they are considered as monoatomic gases. Like I'll show one simple example. Helium and helium combines, it gives a helium molecule do not exist. This molecule do not exist. Why? Explain on the basis of MOT, molecular orbital theory. We know this is a 1s2 and 1s2. By using energy level diagram, we can take like this. This is the energy level diagram for helium molecule. Now this is the 1s2 atomic orbital, 1s2 atomic orbital. Now here 2 electrons, here 2 electrons. 1s of 1 helium, donate 1 electron to this. Again, this also donate 1 electron, it forms 1 electron pair that is entered into the lower energy, that is sigma 1s2. Now this is the here also same situation, entered into the next higher energy, that is a sigma star 1s2. By using this here, a bond order is equals to 1 by 2 into NB minus NA. Now that is 1 by 2 into 2 minus 2, that is 0 by 2, that is 0. Bond order 0 means there is no bond between these helium and helium molecules. That's why here noble gases are colorless, tasteless and monoatomic gases. That monoatomicity explained on the basis of these two important points experimentally. Clear? All noble gases are monoatomic. Radon is a radioactive element. And reactivity of these noble gases. Reactivity of very, very important concept. Next one is reactivity. See here, reactivity of noble gases. Starting itself explain to you these noble gas elements like helium, neon, argon, krypton, xenon and radon. It is a radioactive element. These are collectively called inert gases. Inert gases. Why these are called inert gases means, inert means chemically inactive. So are chemically inactive gases these are. Why these are chemically inactive means, inert means due to the stable octet electronic configuration. Due to the presence of stable octet electronic configuration like NS2 and NP6 electronic configuration. So they do not lose or do not gain electrons under normal condition. That's why valence is equals to 0. That's why they are called zero group elements also. Combining capacity is 0. Valence is 0. because they do not lose, they do not gain under normal conditions. Under normal conditions. That's why they are chemically inactive. However, Mr. N. Bartlett introduced one of the most important concepts, and so many experiments conducted by so many scientists. Finally, that credit goes to Mr. N. Bartlett. Mr. N. Bartlett conducted so many experiments and prepared some important compounds with the help of oxygen. Here, Mr. Bartlett reacted with dioxin, reacted with platinum hexafluoride, this is. So this oxygen reacted with the platinum hexafluoride, it gives O2PtF6, one complex is formed. Now this is the +1 and this is the -1 oxidation state like this. So for this the platinum oxidation state is +4 oxidation state, because here -1 into 6 -6, here +1 into 2 +2, and here +4 required. That's why platinum oxidation state is this. So here the dioxygen between oxygen and oxygen, there is a double bond is there. Yeah, for this to break this bond, some amount of energy required, that is ionization energy, IE. Our ionization potential is here 1170 kilojoules per mole. Amount of energy is required. That is experimentally determined value. That is the ionization energy of a dioxygen. That a dioxin combines with hexafluoroplatinum. Hexafluoroplatinum reacts with dioxin, it gives one complex. That complex is dioxygen, hexafluoroplatinate. Platinate 4 complex is formed. Succeeded to prepare this compound, dioxygen hexafluoroplatinate. So on the basis of the same experiment, for here xenon also, it is a large in atomic size. Xenon also required here 1175 kilojoules per moles amount of energy required. So Mr. N. Bartlett observed here for dioxin ionization energy, this much amount of energy required. Experimentally for xenon also this much amount of energy required. That's why here xenon do not form some complexes with some other elements. On the basis of this, after the preparation of this O2PtF6, Mr. N. Bartlett created a reaction between xenon and PtF6. It gives a orange crystalline solid substance, that is XePtF6 is formed. Now this is the -1, this is the +1. But here oxygen 2 are there, +2, -6, +4. But here the platinum oxidation state is +5. Now this is the XePtF6. This is the orange red crystalline substance is obtained. So here the orange red crystalline substance is obtained by using a simple analysis, like oxygen and xenon both are having comparable ionization energies. Very, very important this is. So here the xenon and dioxygen are having comparable ionization energy. Due to the comparable ionization energy, even though initially they are chemically inactive inert gases, due to the stable octet electronic configuration, under drastic conditions at certain temperatures, Yeah, xenon forms certain compounds with platinum hexafluoride. That's why in examination, one year asked, Mr. N. Bartlett prepared the first noble gas compound is xenon compound is this. That is xenon hexafluoroplatinate 5. I'll write its name. That is on the basis of comparable energies of dioxygen or oxygen atom. They'll ask some questions. Not oxygen atom, molecule. Dioxygen, this is. Oxygen molecule and xenon atom both are having comparable ionization energies. This is very, very important. On the basis, the first prepared noble gas compound is, this is XaPtF6, not O2PtF6. Because in this O2PtF6, there is no noble gas. But in this xenon hexafluoroplatinate, xenon element is there, that is a noble gas. That's why the first prepared noble gas compound is, it is a xenon hexafluoroplatinate. Platinate 5, in bracket we can write a Roman number of 5, that is the oxidation state. That is the first prepared noble gas compound. In examination, if they'll ask, give an example, the first prepared noble gas compound means this is xenon hexafluoroplatinate compound, XaPtF6, not O2PtF6. Now, how to prepare this first noble gas compound by N. Bartlett means like this. Write this reaction. So, while writing this, explain one important point. However, this xenon is a stable octet electronic configuration element under drastic conditions. Dioxide molecule and xenon all are having comparable ionization energies. That's why it readily reacts with PtF6 and it gives the orange red crystalline solid XaPtF6. That is the first prepared noble gas compound by N. Bartlett. After XaPtF6, xenon hexafluoroplatinate, these noble gas compounds, not all elements, some elements like xenon and krypton only forms some important compounds. They are called noble gas compounds. So here finally, noble gases are normally chemically inert. They are not highly reactive elements because of its stable electronic configuration. Under drastic condition, it also forms some complexes, compounds. So here the XaPtF6 is the first prepared noble gas compound. It is first prepared noble gas compound by N. Bartlett scientist. This is, and its name is IUPAC name. IUPAC name is xenon hexafluoroplatinate 5. This is xenon hexafluoroplatinate. In this XaPtF6, oxidation state of platinum is +5, +1, +5, +6. That's why the fluorine is -1 into 6, -6 balanced. After this first noble gas compound, some elements like helium, neon, argon elements do not yet prepared some important compounds. There is no compounds of these elements. But here the krypton forms only one type, that is krypton difluoride. Here the xenon forms with fluorine as well as oxygen. It gives like a different like xenon difluoride xenon tetrafluoride, xenon hexafluoride, with oxygen xenon trioxide, xenon tetroxide, xenon oxidifluoride, xenon dioxidifluoride, xenon oxide tetrafluoride are the some important compounds of xenon. Xenon forms a variety compounds with elements like only high electronegativity elements. High electronegativity elements means here fluorine and oxygen. So after the discovery of this element XePtF6 by N. Bartlett, here the helium neon argon not yet prepared. Here there is no compounds of these elements. Here the krypton forms only one type of element, that is krypton difluoride, not with oxygen. Like xenon forms with both fluorine and oxygen, like these compounds. Tomorrow I'll discuss about preparation methods of xenon fluorides, xenon oxides, xenon oxyfluoride preparation methods, and structures and uses of all these noble gases. Okay, so these are very important. Yeah, important concept is this preparation method